Okay guys, we're going to work through the problems on page 6 of the summer packet. This is all about factoring, which is one of the most important skills that you can have in mathematics, especially as you move into pre-calculus. It's a skill that kids find difficult and that you may have struggled with from time to time, but that with practice you'll be able to master, and that's extremely important for this class. The first thing we need to consider when looking at a problem that asks us to factor is to look for a greatest common factor. A greatest common factor is something that all of the terms have in common. And the terms are all of the monomials or single terms that are separated by addition and subtraction signs. So if you look here at number 1, 5a squared b is one term, and 10a b to the third is another term. And what we're trying to do here is we're trying to first look and see if they have anything in common that goes into both of them, that divides in equally. And here you can see that that's going to be 5. 5 goes into 5, 5 goes into 10. Also a goes into a squared, and a goes into a. And also b goes into b, and b goes into b to the third. So the first thing we establish here is that this does have a greatest common factor, and that GCF is going to be 5ab. So what I'm going to do at this point, when I have 5ab, is I'm going to then take 5ab and I'm going to divide it out of each term. So once I have the GCF, the idea is to make this simpler by removing it or using the distributive property backwards or dividing it. They're all the same thing. So here I have 5ab and I'm taking it out of this. So 5a squared b divided by 5ab. 5 divided by 5 is just 1. A squared divided by a is a. B divided by b is just 1. So I just have a left over. I have the plus, and now I divide 10 by 5 and get 2. Divide a by a and get nothing. It cancels. It's just 1. Then b to the third divided by b is b to the second. So now I've made this simpler. And I know this works because if I distribute it and go backwards, I get what was here originally. This in the parentheses does not go any further, so this is my final answer, which is found by just taking out the GCF. Number 2, we look also for GCF, but it doesn't have anything in common. This has an x and an x squared. This has 5 times 5, so it doesn't work out. But we do notice that this is a difference of two squares. X squared, that's a perfect square, and 5 squared is 25. So what we do here is we just follow the pattern listed on page 6, which tells me to break this down, take the square root of the first term and I get x, so I put that in both the first positions. And then I take the square root of 25 and I get 5. So I put plus 5 and minus 5 and I'm finished solving this problem. When you notice that something satisfies the difference of squares pattern, it will always be this pattern. It will be take the square root of the first term and put it first, take the square root of the second term, put it second, put a plus, put a minus, you're done. If we look at number 3 has a GCF. That GCF here is x. So I'm going to take that out. So x squared divided by x is just x. 6x divided by x is just 6. So I've now made this simpler and I'm finished. Number 4, it's difference of squares again. 1's a perfect square, so is 9x squared. So I take the square root here of 1, and that's 1, so I put that first. Take the square root of 9x squared and I get 3x, so I put plus 3x and I put minus 3x, and this problem is now finished. Now we start to get a little bit harder here. Number 5, it has an x to the third power. When you have an x to the third, it's kind of a giveaway that it should be grouping, which is also listed on page 6. What I'm going to do when I group is I group the first two terms together by adding parentheses. I group the last two terms together by adding parentheses, and I go from there. Now I look for a GCF. The GCF here is going to be 3x squared. So I take that out of the first term, so I get 3x squared, remove it, I get 2x left, and a 3x squared taken out of here gives me a 3 left. Now this doesn't have a GCF, so because it doesn't have a GCF, I'm going to pull out a 1, and I have 2x minus 3. So now I notice that the 2x minus 3's are the same, which is what I want, so therefore I'm going to rewrite that down here. That's one of my factors. And then my other factor is going to be the 3x squared plus the 1 that's left over, and I have now factored this problem. That's not easy, but the idea is the more you practice, it will get better. And you know, basically, if you need help, just let me know, and there's lots of ways that we can work on these together. Number 6, it looks like it could be difference of squares, but this is not a perfect square. So what we're going to do first is we notice that it has a GCF. 5 goes into both terms. So I'm going to take the 5 out first, and then I get x squared minus 4. Now we know that this is a difference of squares in the parentheses. So I keep the 5, and now I can break down the x squared minus 4 into two more things. I take the square root of x squared and get x. Take the square root of 4 and get plus 2 and minus 2. And this problem is now finished. So it was combining difference of squares with GCF to do both types of factoring in one problem. If you look at 7, 7 does not have a GCF. It also does not have two terms, so it can't be difference of squares. It has three terms. So this is just going to be basically our guess and check model. So what we're going to do is we're going to make a little table over here. We're going to look for two numbers that multiply to give me 15, and they must add to give me the middle number, which is negative 8. So I think about that, and I think about, well, maybe we can do negative 5 times negative 3. Negative 5 times negative 3 gives me positive 15. Negative 5 plus negative 3 gives me negative 8. So now that I've found my numbers, all I need to do is write down x in the first place. I'm going to write down minus 5 and minus 3 because those are the numbers that worked in my tree. So I'm finished. Number 8, a little bit harder. They said to do this by grouping. So the first thing we're going to do is we can do that method, and then I can show you the box method on number 10, which is also similar to number 8. So the first thing we're going to do here, when you notice the first number in front of x squared is not 1, it's a 5. What we're going to do is we're going to multiply that number times the c, which is the number without a variable. So the first thing I'm going to do is take 5 times 2 and get 10. So I'm going to make my little chart again like I did in the previous problem, but now I want two numbers that multiply to give me 10 that add to give me the middle number, which is negative 7. I'm going to think about that, and I'm going to come up with negative 5 and negative 2, because negative 5 times negative 2 is going to be equal to 10, and negative 5 plus negative 2 is going to be equal to negative 7. So now that I have this, it's going to be a little complicated. I'm going to break this middle term up into these two terms. So I'm going to rewrite the problem by keeping the first one the same, but then instead of writing minus 7x, I'm going to write minus 5x and then minus 2x, because those are the two numbers I found, and I'm going to keep the last number plus 2 the same. Now I'm going to group, so this becomes a grouping problem like we had earlier in this problem set. What I'm going to do here is I'm going to find the common factor, which is 5, take it out. It's actually 5x. I'm going to be left with x minus 1. And then I'm going to find the common factor here of 2. So I'm going to take out negative 2, and that's going to leave me with x minus 1. See, the x minus 1 is in common, and the 5x minus 2 at the end. So my final answer is x minus 1 times 5x minus 2. This problem is solved. We're going to apply this down here to number 9, but number 9 has a GCF. All three terms are divisible by 2, so I first take the 2 out of them. So I am left with x squared minus x minus 12. I'm now then looking at this middle section, bringing the 2 straight down, and then trying to break the middle section into two more parts. I'm going to draw myself a little tree. I want two numbers that multiply to give me negative 12 and add to give me negative 1. Think about it for a second, and I come up with negative 4 and 3, because negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So then this gives me x minus 4 times x plus 3. And when I do that, I see that it works out, and I'm finished with this problem. Now, if we look at number 10 here, number 10 is similar to number 8, but I'm going to do it in the box method way. The first number is not a 1, it's a 6. So I know that I'm going to have to do some sort of weird thing here where I multiply the first number times the last number. So I'm going to do the same thing here. I take 6 times negative 1 and get negative 6. So I put that in my chart. I'm looking now for two numbers that multiply to give me negative 6 and add to give me the middle number, which is negative 1. So I think about that for a little while, and I come up with negative 3 and positive 2. So negative 3 times 2 is negative 6. Add them together, we get negative 1. Now, instead of doing this grouping method, which sometimes confuses students, what we're going to do is we're going to do a box method. Now, you might know the box method for multiplying, but we're going to do the box method for factoring. You draw a box. In the box, you're going to put the first term here, so 6x squared. You're going to put the last term here, which is -1. You're going to take these two numbers that you found here, and you're going to put them in the box, -3, +2, and you're going to add an x for each of them. Now all you're going to do is you're going to look at each row and column and find the greatest common factor. So I'm going to look at the rows. So if I look across here, and I look for the greatest common factor between 6x squared and 3x, I come up with 3x. So I put 3x on the outside of my box. Do the same thing with this row. The greatest common factor between 2x and -1 is just going to be +1. Then I'm going to work with columns. So I'm going to change colors here so you can see it. I'm going to look at this column, 6x squared and 2x. And what I'm going to do here, and I have no idea what just